So then how does fructose actually stimulate food intake? Because remember I told you that when we put fructose in the water, the first 2 weeks they didn't really eat at increased amounts of chow, but after a while they just became so hungry they kept eating everything. And it turns out that it blocks a major satiety pathway. Years ago, Friedman showed that there's a hormone called leptin. And leptin is a hormone that tells you when to stop eating. And so when you eat food, the leptin signals to the brain and says, hey, you're full. And normally animals are very leptin sensitive. And if you feed them too much food, they'll quit eating, or the next day they'll eat less, or they'll exercise more. They maintain their weight. But people who are overweight, people who are obese, tend to become leptin resistant. And so, it turned out that if you knock out leptin, animals become very fat. So for a while, everyone thought, we can cure obesity by giving leptin to people. But the trouble is, people who are overweight are resistant to leptin. They develop a resistance to leptin. And what we found was that fructose causes leptin resistance. The way you do that is you take an animal and you inject it with leptin, and if you do, it will reduce its food intake. And it's like small amounts. It's like 10%. And you can see here on the left that, if you put an animal on a high-fat diet, they'll stay leptin sensitive. And so you can actually block food intake by giving them leptin. But if you give them fructose, they become leptin resistant. And then if you stop giving them fructose, they'll stay leptin resistant for a couple weeks, and then leptin sensitivity will occur again. In our hands, if we give lard to an animal that's leptin sensitive, we can't make the animal fat with a high-fat diet alone. But once we make them leptin resistant, they get dramatically fat with fat. It turns out that fructose makes you hungry by creating leptin resistance. And that's why when you add fat, you become really fat, because now you're hungry, so you're going to eat those French fries and all the fatty foods, and you're going to gain a lot of weight because you can't control your appetite. And that's why when you're on a low-carb diet, you can eat a high-fat diet, and you're not going to gain weight because you're leptin sensitive. And that's why when you go on a low-fat diet, you have to do caloric restriction because you're on high carbs, so you're going to be leptin resistant. So the benefit of the low-carb diet is to give you leptin sensitivity. That's one of the many. So that says that when you eat carbs, you become leptin resistant, and that makes you want to eat more. So is it just about calories? Is it just the fact that fructose makes you want to eat more calories? So what we decided to do is to do studies where we pair-fed animals, where all the animals would eat the same exact number of calories. You aren't going to let them eat more. They may be hungry, but you're not going to give them any more. All the animals eat as much as the guy that eats the least. So every day you count how much food is eaten, and if this little guy over here eats very little, then the next day everybody has to eat just that small amount. And so when we did this experiment multiple times, but it was very interesting. We put animals on either starch or sugar. And, so there was one animal who turned out to have cancer, so he wasn't eating very much. So it turned out all the animals ate very little. They were eating like 80% of what they normally ate. And at the end of 3 months or 4 months, we looked at them, and weight gain was the same. Or actually, there was no change in weight. All the animals, there was a tendency for a little bit of weight gain in the sugar animals because they dropped their basal metabolic rate a little bit, but it wasn't a lot. It really was subtle. But we still saw dramatic changes in metabolic parameters. The sugar-fed animals, even on a diet, became diabetic. Every one of them became diabetic. Every one of them developed severe fatty liver, as shown here. They developed hypertension, hypertriglyceridemia. They had visceral fat. They were a mess inside. So it turns out that sugar and fructose drives weight gain by making you hungry. And that is how weight gain goes. And that's why the energy balance people are right. Weight gain is an energy balance equation. But the metabolic components, the diabetes, the fatty liver, and all that, that is independent of weight gain. You can be on a caloric restricted diet, but if it's high in sugar, beware. So as we started studying this, I was focused on fructose. So I thought to myself, so fructose is the bad guy. So when you're eating sugar, you're eating fructose and glucose, because that's what makes up sucrose and high fructose corn syrup. And so the question was, is glucose safe? And of course, this was going against, what everyone was saying, glucose stimulates insulin, insulin causes obesity. But we were finding fructose to be the culprit. So what about glucose? Could it be causing obesity? So we put animals on glucose in their drinking water, and they do get fat. They got fat, they got insulin resistant, they got hypertriglyceridemia, all the features of metabolic syndrome. They became leptin resistant. So it seemed like both sugars were bad. And so now I was kind of puzzled because we had two mechanisms. We had this glucose pathway that stimulates insulin and could cause fat that way. And we had the fructose theory where fructose is dropping energy and that's causing fat. And so the question is, both are important, and I think both are important. But I'm going to show you that the fructose one is particularly important because we had a surprise. We discovered that fructose can be made by glucose at a level that can cause obesity. And so that when you eat high glycemic carbs, you can actually start making fructose in your body. And the way it works is this way. There's only one way this can happen. There's only one known pathway, and it's called the polyol pathway. And when you eat glucose, it can be converted to sorbitol and then to fructose. By the way, sorbitol is that artificial sugar they put in syrups. It makes fructose and it gets into your body. So, so much for that. Okay, so anyway, glucose gets converted to fructose. And interestingly, what drives that pathway is glucose loading. So if an animal has diabetes with high blood glucose, or a human with high blood glucose, they're making fructose all the time. It's been shown. They don't have to be on fructose. You can measure fructose in their blood and in their urine, especially if the diabetes is out of control. If you go on a high glycemic carbs, you're going to make fructose too. That's now been proven in studies that were done in Switzerland. And high carb diets will also generate fructose. So basically, when you go on a low carb diet, you're blocking this ability of glucose to generate fructose because you're removing substrate. So when we put animals on glucose, we found that they actually did make fructose. So these animals were not being exposed to fructose, but we found that there's a baseline fructose level in animals, and it goes up when you eat a high glycemic diet. And it's associated with all those features, but if you knock out that fructose enzyme, so that insulin's still working, all those things are working, you find that you can block fat, obesity, insulin resistance, and fatty liver by just blocking fructose metabolism. It's not complete. There's definitely an insulin pathway there. So if you look at the fat, about half of the fat comes from insulin and half the glucose-insulin pathway and about half from the glucose-fructose conversion. So both are important. But it's really more dominant. The fructose pathway is more dominant. So this is a study where we gave soft drinks to mice, and some of them lacked the ability to metabolize fructose. They were KHK knockout. So these mice cannot metabolize fructose, but they have an intact glucose-insulin pathway. And again, what we've seen is that we can block weight gain, triglycerides, insulin resistance, diabetes, fatty liver. It's dominant. So the dominant mechanism when people eat carbs, the dominant pathway for causing obesity appears to be through the fructose pathway. And the insulin pathway is important as well.